Okay, so the reference number is going to be the shortest distance traveling along the unit circle to get to the x-axis. So in this case, the shortest distance would be to travel right back to this x-axis. And so in this case, it's the same distance. So t is going to be equal to t bar in this case. They're the same. But like Trevor was saying, if we were to travel, say, all the way around the unit circle and stop here, all right, this is my t. But now, the shortest distance to get to the x-axis is going to be going down to this point here. So in this case, going from here to here is my t bar, is this one right here. Okay? And you don't need to stress too much about t bar. It doesn't come up a whole lot. The reason the book brings it up is we're going to use this t bar, this idea of t bar, and use all of the symmetry that exists in the unit circle to help us find the actual t value and to find the actual coordinates. Okay, so what I'm getting at here from yesterday. What's that? This?
Yeah.
It's t bar. So it's this?
Yeah.
It's just an arrow. Just pointing. Brilliant. Okay. The point that we're getting at here is, if you really listen up. So really, for the majority of this unit circle, especially when it comes to the ordered pairs, right? The only ordered pairs you really need to memorize are the ordered pairs from the first quadrant. You only really need to memorize these ordered pairs from quadrant 1. Why? Well, because the only thing that changes in the other quadrants are the signs of the x and the y, right? Positive, positive, negative, positive, negative, negative, positive, negative. So what matters is to realize that there's y-axis symmetry in those ordered pairs, right? So for instance, if I pick 30 degrees here, the ordered pair was root 3 over 2 comma 1/2, and if I reflect that over, this is why I drew that rectangle in, it was negative root 3 over 2 comma 1/2. It was the same numbers, but I just had to change the sign. Make sense? Okay. And then there's also x-axis symmetry as well. So if I went to this 30 degrees and followed this kind of rectangle and reflected over, it's also root 3 over 2, and now it's comma negative 1/2. I just had to change the sign. And the same thing for this point over here. So those 4 points have all the same numbers with the exception of just changing the signs. Right? Does that make sense? So all this symmetry is going to come into play. Well, using this idea of t bar, all of those 4 points are going to have the same t bar value. So if I pick this point here, what is the t bar value? How far away am I from the x-axis? Right here. Pi sixths. If I go over here, how far away am I from the x-axis? Pi sixths. If I come here, the closest distance would be to travel backwards. But how far away am I? Pi sixths. And over here, how far? Pi sixths. We only care about, good question. So Trevor asked, is it negative? the t value, not t bar, the t value is always positive for counterclockwise and negative for clockwise. The t bar is only distance, and distance is always going to be positive. Okay. So we don't care which direction we go. All we care about is what is the shortest distance I have to travel to get to the x-axis. And the reason is those points that have the same t-bar value are all going to have the same numbers for the ordered pairs, with the exception of changing the signs around. Does that make sense? Okay. This is also going to come into play because what we're going to do is, because this is a circle, I could actually travel around the circle more than once and stop somewhere. Does that make sense? So this point here is 0 pi. If I go all the way around, it's 2 pi. I could go all the way around again, and it would be
3 pi, 4 pi,
4 pi, 6 pi, 8 pi. I can keep doing this as many times as I need to, and I end up in the same place. Okay, or over here, 1 pi. If I go around again, 3 pi.
What?
Every time you go around the circle, it's 2 more pi. So I start out at 1 pi, 2 pi, 3 pi, 5 pi, 7 pi. Okay, you guys kind of seeing this? Well, now they're going to get a little harder, because like maybe I'm here at pi halves, and if I go all the way around,
3 pi halves. No.
5 pi halves, because I need to add 2 pi, but I need it to be in halves.
I need to add 2.
Every time I go around, it's 2 pi.
Yeah. So that should make it 4 of them. Halves.
Yeah, so you're adding 4 halves.
Pi halves plus 2 pi, but they don't have a common denominator. So I need to do, I need to do pi halves plus, what's 2 pi with 2 as a denominator? 4 pi, and so it's 5 pi halves. Okay?
I don't remember.
Well, what are we
So-
talking about? How many times it goes? Oh my god.
Well, what we're getting at is I'm going to give you t value, and maybe the t value is something like 21, must be, say I give you 21 pi fourths. Well, that means you've gone around the unit circle at least once. But where do you end? If you keep going, where do you end? You're going to land on one of these spots that we already have labeled. 21 pi fourths. Okay, let's... Well, okay, here's 1 pi fourths, right? 2 pi fourths, 3, 4, 5, 6, 7, 8 pi fourths, technically. Isn't that true? 8 pi fourths?
What?
Wait, are we talking about starting at the 0? I still don't understand.
Okay, we have a guess for 225.
Wait, where are we starting? Is it just...
You always start here. Okay, we're thinking fourths. I said 21 pi fourths. So if you go around the circle, what is 2 pi if we're talking in terms of pi fourths?
8 pi
8 pi fourths is the same. So I go around 8, and then I go around another 8, which is 16 pi fourths. Okay, 17 pi fourths, 18 pi fourths, 19 pi fourths, 20 pi fourths, 21 pi fourths lands on the same place as 5 pi fourths, and we call those co-terminal angles because you end up at the same place. So if I say 21 pi fourths, you're going to be saying, well, that's the same as 5 pi fourths. I don't expect you to memorize 21 pi fourths, that would be silly, but you need to figure out where that would land on the unit circle, and it's the same point as right here. Okay? Does that kind of make sense?
No.
Yes. Yes. So basically, when we're thinking about reference numbers and we're trying to find the shortest distance to the x-axis, there's only 2 points on the unit circle that are on the x-axis, and it's either going to be this point, which we'll call 2 pi probably most of the time. It depends. And this point, which is 1 pi. Okay, and so you're going to have to always think, which one am I closer to? So in this case, 5 pi 6, which one is that going to be closer to? Is it going to be closer to 0 pi or 2 pi, or is it going to be closer to 1 pi? It's closer to 1 pi, because that's over here somewhere. So since it's over here somewhere, all I need to do to find the distance, I guess yes, exactly. If you want a little sketch to help you think about what we're doing, you don't have to do sketch, but just to show you, if this is 5 pi 6, I'm trying to find this distance right here, and whenever we want to find distances, we subtract. So we're going to take, all we have to do to find t bar is to take pi, and we're going to subtract off 5 pi sixths. Common denominator, so we need to turn pi into 6 pi sixths and subtract off 5 pi 6, and so the t bar is just pi 6. Well, we're going to do some, we're going to do some more. That was the first one. Okay. Well, let's try it. That's up to you. Whatever you want in the notes. These are the examples right in the book on page 414. Okay. So B is t equals 7 pi fourths. So again, you don't have to sketch it, but it might help, or pull out the big diagram that we made yesterday. Okay. So 7 pi fourths, where does that fall?
315 degrees.
Ah, so that's over here, isn't it? So this is 7 pi fourths, and the closest distance here is going to be to 2 pi. And this is the t bar that we're looking for. So to find t bar, we're going to take, this time, we need to take 2 pi, because it's closest to 2 pi, and subtract off 7 pi fourths. So now we need to turn 2 pi into a fraction with,
Pi fourths.
it's got to have the same denominator. 8 pi fourths is the same as 2 pi.
So it's pi fourths.
Minus 7 pi fourths gives us 1 pi fourths.
Okay, but what about like the 21 pi over whatever?
Okay, well, yes, that is a good question. Just what he wants. Okay, part C, or example C. It is t equals negative 2 pi thirds. Ooh, negative this time. Okay, again. That's a good Barney impression there. You guys grew up with Barney?
Yes.
Okay. Huzzah. Alright, negative 2 pi thirds. Where's that going to land?
It's going to land at 225.
The answer is pi thirds.
Tremendous.
Where's 2 pi?
It's going to land at 210.
2 pi thirds is at 120, but if you answer negative.
Negative.
240.
That's going to land at 240.
Ah, I think it's going to be over here, right? 1 pi thirds, 2 pi thirds, in the negative direction,
4 pi thirds.
right? This
It's negative.
is
So the opposite
t equals negative 2 pi thirds. Yes, because 2 pi thirds would normally be here, but we're going backwards, so it's going to be here. But we want to find t bar, and t bar is this distance here, the shortest distance to the x-axis. So what do I need to subtract it from?
Pi.
Pi.
What was the question? Wait, pi minus, wait. Is it pi plus? Is it pi plus? Because
Okay, good question. So now we're starting to think t bar. I need to do pi minus, am I going to subtract 2 pi thirds or negative 2 pi thirds?
you're going to add 2 pi thirds.
Well, if I subtract a negative, it would be adding, but then I'm going to get pi plus 2 pi thirds.
Or just get rid of the negatives and think of it as a distance.
Yes, it's exactly right. These are distances, and distances can't be negative, so we're only going to keep them positive. Here's a follow-up question. What is the absolute biggest t-bar value that you can have? What's the furthest you could be from the x-axis at any time?
1.
Say it again? Pi halves, right? If you are at 90 degrees here at the top, or even if you're down here at 270, that's the furthest that you could be from the x-axis, and it's pi halves in either direction, so it doesn't matter which way you go. And so you should never have an answer that is bigger or greater than pi halves. They should always be between 0 and pi halves. So we're just going to think of this as a distance. We're just going to subtract off 2 pi thirds. And that's going to say, well, this is 3 pi thirds minus 2 pi thirds. And that's going to give us pi thirds. Okay.
So they're gonna
Okay,
hear,
the last one here.
Does it have audio?
they're gonna hear Emily yelling that she's bullied.
The last one, t equals 5.80. Wait, what? That's not even in terms of pi. That's weird. Okay, well,
You take pi you divide that by pi.
let's think about pi in terms of its decimal equivalent. So if this is normally 2 pi,
Oh, it's gonna be
what is 2 pi in decimal?
5. It's 2 times that.
2 times 3.14, which becomes 6.28, approximately.
So that means it's less than.
So we're at 5.80, so which quadrant are we going to be in, probably? Looks like, yeah, we're probably going to end up being over here in the 4th quadrant somewhere. So, right, we go all the way around, and this is a t of 5.80, and we want to find t bar. So t bar. So it is technically going to be 2 pi minus the 5.80, which is approximately going to be the 6 point. We always want to try to be on time for break, huh? Going to be in the habit of 3 decimal place accuracy. So 2 pi is 6.283, and subtract off 5.80, and so we are going to get an answer of 0.4.
Where's the 5.8? Oh, no.
483 is going to be our answer. Okay, so I'll add my own example, which is we'll do the 21 pi force. 21 pi force. So the point is,
So on that last one,
yes.
t bar equals 0.43.
Yes, you can leave it as a decimal. You'll usually have fractions of pi, but this one they didn't. They used a decimal, so you get a weird answer. Okay, so if we go around the circle one time, we've gone around 2 pi. But we are in fourths now. So 2 pi is the same as how many fourths? It's 8 pi fourths. Does that make sense?
Okay, and so does each fourth one extra one then on the top?
So this is 1 pi fourth, and this is 2 pi fourths, and this is 3 pi fourths,
So
4 pi
that
fourths,
would make it 9 pi fourths.
9,
pi
10,
fourths.
yep. And that's it all the way around. But technically, if we go around once, it's 8 pi fourths. If we go around again, it's another 8. So that's 16 pi fourths. We still haven't even got there. So we had to go around twice and keep going.
Okay.
So 16 pi fourths, and then 17 pi fourths, 18 pi fourths, 19, 20, 21. So we're going to end up here.
Okay.
this is going to be 21 pi fourths. But really now, we went around once, which was 2 pi. We went around again, which was another 2 pi, so that's 4 pi. And then we came to here, which was 5 pi. Okay? So really, what we would like to do is I want to find this distance from here to here. And I guess there's two ways of thinking about it, right? We could subtract them, but if we did the smaller minus the bigger, we're going to get a negative. We know the distances can't be negative. I guess we could take the absolute value, or we could just take the bigger minus the smaller and be safe. Does that make sense?
Well, can't you just change it to, 5 pi fourths, because it's the same.
Well, okay. Yeah, when you have the picture there, yes. Doing it algebraically by hand, we're going to prove that it's the same because this is going to be 5 pi. So we're going to do 21 pi fourths, this point. We're going to subtract off this point, but I went around 2.5 times, so that's now 5 pi. But we can turn this into fourths, so 21 pi fourths, subtract off, turn 5 pi into 20 pi fourths, so 21 pi fourths minus 20 pi fourths,
1 pi fourth.
which is 1 pi fourth, which is exactly the same t bar that you would have got calling this point 5 pi fourths.
Okay.
Yes. So here's what I'm getting at. I'm not always going to make you do this work for t-bar by hand, right? My hope is that you understand the unit circle well enough that you can just in your head say, okay, I go around 1.5 times and I end up here, okay, I know what point we're talking about. So I hope that this is why I want to take that quiz, and I want you to have the unit circle like down so that you don't have to do all this algebra, that you can just say, I know where we're talking.
Well, isn't technically all the fourths pi fourths?
Right? So the whole point is that I'm going to say, what is the terminal point for 21 pi fourths?
It would be
Well, we just found out that 21 pi fourths is here. So what is the terminal point, or what is the ordered pair?
negative
Root 2 over 2
minus root 2 over 2.
negative root 2 over 2. That's the whole point. Okay?
I don't like this.
All right. Example 6 here is what I just said we're going to find the terminal point for each t.
So on our homework, do you want us to mathematically find all of these? Like we can't just write it from our notes?
Let me think about that for a second. Let me do this, and then I'll think about it, okay? So these are the same t values that we just did, but now we need to find the terminal points. So 5 pi sixths, right? We already did that back in 5a. 5 pi sixths had a terminal, a reference number of pi sixths. Why does that matter? Well, we already had that point on our unit circle, but the reason the terminal point matters is because if I go back, this is getting at what you said, Trevor, we only really need to know what is in quadrant 1. So I go back to our main unit circle, quadrant 1, and it was a reference number of pi sixths, and so I'm going to reference this ordered pair. So all I need to do is take this ordered pair and give it the right signs for that quadrant, and I'm done. And we know it's in what quadrant? 5 pi 6 is in quadrant 2. So all I need to do is put the negative in front of the x, and I'm done. That's the whole. We're referencing everything from quadrant 1 that has the symmetry of the point that we're looking for. So this, we can just say that the reference point or the terminal point, sorry, is negative root 3 over 2, comma, 1/2. And that one's done.
So we can just use our notes.
Wait, can you go up?
Yes, sorry.
So
Okay.
we can just use our notes and change.
Yes. Okay. B. We already did B. It was a t value of 7 pi fourths. Okay. We already calculated on the previous page that it had a t bar, it had a reference number of pi fourths. So I go back to my first quadrant and I go to pi fourths, and here's my point, and all I have to do is put the right signs in and I'm done. The y is negative because we're in quadrant 4. So I go back and I say it's got to be root 2 over 2 comma negative root 2 over 2. You guys see why it's called a reference number? Because you're just referencing quadrant 1 and changing the signs. That's all you're doing. Okay? And so then the last one, C, was t equals negative 2 pi thirds. Okay, we already calculated that that had a reference number of what? Pi thirds. So I go to quadrant 1. I go to pi thirds. Here's my reference, and I'm in what quadrant? For negative 2 pi thirds, put us in, that one was in quadrant 3. So I need to make both negative, and I'm done. So this is going to be negative 1/2 comma negative root 3 over 2.
How are you finding?
So there is the homework.